Hi, I'm Sri Peruvemba. I'm here with Dr. Kane to talk about flexible displays. So thank you, Paul, for agreeing to do this.
Sure.
Both of us have been in the industry for a while. We're very fascinated with these kinds of technologies. You have on your hand a rolled or a curved display. So I always believed with an LCD, being that there are two sheets of glass, a rigid structure with spacers maintaining that gap, because the cell gap is extremely important, isn't it, to have the performance. How the heck did you guys make this?
Yeah, okay. Well, you're right. I mean, normally displays will be made out of glass and would have transistors made of silicon on glass. And so what we've developed, and our core technology, is a way of making transistors on plastic. So these are organic transistors, and they're printed and patterned onto plastic sheets like PET, and that enables us to print transistor arrays for displays directly onto plastic, and that makes the display ultimately flexible, because it means we can remove the two sheets of glass that are normally used each side of the cell to make the LCD display.
And what about the transparent conductors that you have in there, the electrodes?
Yeah.
Right? Are you still using ITO, or are you using alternatives to ITO to make these?
Well, I can't go into specifics on materials that we're using, but to say this is an IPS mode display that we've made. So that and actually we're using completely standard liquid crystal in this stack here. So actually we have no issues in terms of using brittle layers that might crack if it's bent too far.
I see. Wonderful. So you have a curved format of a device that can be wrist worn.
Yes.
Of all the different applications that you see in this space, is this likely to be your first foray into the market, or are you looking at other types of applications which you believe will be among the first ones to be successful commercially?
Yeah, so I think the first ones to be successful commercially are likely to be mobile devices and wearables. So either the ability to flex a display around your wrist gives you more utility for the device, or to have devices which are unbreakable, so they can be dropped and thrown around much more than they could otherwise be. Precisely.
And you also have the advantage that with these flexible materials, it's a lot lighter than if it is glass, isn't it?
Yeah.
How much lighter is it?
A lot lighter. I mean, for instance, as an example, we did a calculation recently. We looked at it. If you on an aeroplane replaced every in-flight entertainment screen with a plastic one, you'd actually, for a 10-inch screen, you'd save several $100s over the life of that entertainment system per seat on fuel alone, and that's just from weight. So that's all value that the display is bringing directly.
Absolutely. And can you use your backplane technology outside of LCD? Can you, for example, use them on electrophoretic displays? Can you use them on OLEDs and other technologies?
Absolutely. So they're already used on electrophoretic displays today. You can buy e-paper displays that have use our technology in the backplane to make them flexible. You can also use them for OLED displays. We're showing some examples here of flexible and virtually foldable OLED displays made with this technology also.
Switching back to applications, you've cited several examples from automotive to wrist-worn devices to unique forms of mobile phones and so on and so forth. If you were a betting man, I'm hoping you're a betting man, and if you were to only pick one of these applications that will be successful in the next year, maybe no more than 18 months, what is that one bet that you would make?
Yeah. Well, I'd say mobile devices and wearables.
Those will
in the
be
first.
your bet. And if you were also a betting man on the other side of the spectrum, what is an application that people are asking you to develop a product for that you don't believe will take off, at least in the near term?
I think it's more likely we'll see smaller displays first, and then later we'll get to larger displays. So larger things like digital signage, for example.
Do you see a role for quantum dots to be incorporated along with your flexible display technology?
Yeah, absolutely. And I think it's an interesting and yet another example of how OLED displays and LCD displays, fight back against OLED performance. And yet again, we see another example of how LCD can improve its performance, not only in color gamut, in contrast, in brightness, and now in flexibility as well.
So, your company has been developing this technology for a while, and you've got a lot of traction in the market. Do you still have technical challenges that you need to overcome before you're able to commercialize the technology?
So for the LCD display that we just showed you, that's ready for prime time now, and we're working with display makers to get this into mass production. Our goal is to license this technology. We're not building a factory ourselves. We're going to enable existing manufacturers, and part of the reason we're doing that is that we've quite purposefully designed the process to be highly compatible with existing amorphous silicon TFT LCD lines. These transistors are now at a performance point of well beyond amorphous silicon, sort of mobilities of 1.5 centimetres squared per volt second, much more stable and highly uniform over large areas. And so with those parameters, there's so much this technology can now do, and so that's why it's ready now.
It's wonderful. Now, among these different forms that you've created, you've got examples of these, curved display, and I've seen examples of rollable displays that you have previously created. Where do you see these in terms of a roadmap? And is there a room for those foldable displays too? I always assumed it's curved, foldable, and then rollable, but you've done rollable and you've done curved. Have you made foldable displays?
Yeah, I see. So definitely see the same roadmap as you, starting with this curved conformed and then getting to rollable and foldable. We're currently doing testing on OLED displays, which are, we believe, to get to foldable you need O on the top and O on the bottom. Yeah. And so a completely organic stack. And we're today making displays that we can bend whilst they're being driven to a 3mm bend radius thousands of times whilst they're being driven. We're pushing that further forward. But ultimately, we know the transistors themselves. I mean, we showed some testing results a couple of years ago where these TFTs, we can bend to a radius of 0.25 millimeters. So that's literally around a matchstick or less, 10,000 times with no change in the threshold voltage or on current, no change in the parameters. And so they are fundamentally super flexible, and that's because there's no ceramic layers in there.
Have you also tried ITO alternatives with your material, like silver nanowires? Have you tried metal meshes? Have you tried carbon nanotubes and those kinds of things?
That's right. We have indeed, and including graphene and graphene-like materials, which is also a focus of ours.
Okay, so your material stack is compatible with all of these other alternatives?
Yeah, we began developing our process, over a decade ago, and it's very much around solution processing and low temperatures. So, for example, when we make the backplane, we don't have to go above 100 degrees C. And it turns out many of those processes, solution processing, patterning methods that we've developed, are highly relevant to putting down, graphene-like materials, for example.
In terms of color gamut, which, as you know, is a big deal when it comes not just for smaller displays, but larger displays as well. In your process, is there a sacrifice in contrast or in the color gamut with your stack?
No. So, what you're looking at here is a prototype, so color can be further optimized. But this is an IPS, an in-plane switching structure. The transistors are better than the amorphous silicon that we're using. And in a production environment with production equipment, the performance could be every bit the same as a glass equivalent to amorphous silicon display. Yeah.
And then, I always joke about this in our industry. What's the most important spec in a display? And typically, the answers you get is contrast, it's brightness, it's viewing angle, it's all of these things. And I always say that's not the most important spec. The most important spec, by the way, let me test you. What is the most important spec in a display?
Well, let me talk about cost, perhaps.
Exactly.
So,
what is the most important spec for an electronic?
Yeah.
Cost-wise,
so cost-wise, in production, these will be the same cost to manufacture as a glass display, which is much lower cost than any other flexible display technology, and that's the point. And that's precisely because we're making this using a TFT LCD amorphous silicon type line. We're removing the glass from the bill of materials twice. Yeah. We're introducing some new materials, of course, but overall that means this can be done at very low cost, and that's the key point.
And, in terms of where you are to commercialization, have you had the product tested in the field with customers or even in-house testing? What kind of tests have you performed to give yourself the comfort that it's got the lifetime, it's got the durability, and so on and so forth?
Yeah. So we know the transistors themselves are already used in other products for e-paper displays. Yeah. And they're available now in products today. And so what we're doing now is testing it with this construction for LCD, which is an entirely standard construction in terms of the front plane and the back plane in terms of the type of LCD mode that we're using. So we're very confident about the performance of the platform.
So let's talk about touch screens on top of these flexible displays. As you make it thinner, it's always a challenge, right? Particularly if somebody just if you have a flexible material, there's no rigid support in the back.
Yeah.
Tell us about what kind of touchscreens have you tried? What are the touchscreens that work with your material?
Yeah. So first of all, the way we've defined the cell gap in this structure is one which has very good resilience to push Mura. So actually better than many glass displays when you have a look at the surface. And so we can either put touch on top. We've done that. Obviously, we don't focus on touch ourselves as a technology, but we work with use partners materials. We can laminate flexible touch on top. There are many companies making that today. But also with flexible displays, you can put touch behind the display because the display will locally deform. And so that means you can still get a very good sensitivity with touch systems which need not be transparent because they're behind the display rather than in front. So it actually gives you more options for flexibility.
Do you see the education market as a potential venue for your products in terms of having kids with electronic devices? These are obviously unbreakable compared to glass.
Yeah, I think both actually, I agree entirely, and both actually for the young and the elderly, there's actually a market there, yeah.
And perhaps also in the heavy industrial and military and so on, there's equal number of opportunities, isn't there?
Absolutely, and an extension to that is something like a wrist wearable display where for having both hands-free for productivity, you can actually do whatever you need to do and have the information and instructions to hand.
If it is your wish list, what would you like customers for FlexEnable to do that they're not doing today other than giving you purchase orders? What are the kinds of things that they should be thinking about that will enable them to work with you?
Well, for us to clearly understand what they need and what's the size of displays, the performance of the display that they need, and we can factor that into the platforms that we make.
I was hoping you would say they keep giving me these rectangular display specs when you can make pretty much any shape.
Well, that's true. That's true, actually. One point I didn't mention earlier is that one of the benefits of doing this on plastic is that you can cut the displays with a laser to unusual shapes very easily. So if you need a hole in the middle of a display because you want a needle or, I don't know, a pair of watch hands to stick through it, then that can be done quite easily, which is not so easy with glass.
Right. Awesome. Wonderful. Thank you so much. Would you like to tell our viewers as to, are there other products here that you'd like to demonstrate? You have a demo here.
Yeah, so let me just show this. This is a flexible fingerprint sensor, which is made basically using our transistor array combined with an organic photodiode layer from a company called iSorg, who are also here at this show this week. And so together, this is very much like a display in its cost structure and in the way it's made, which means we can have large area and make the whole area fingerprint sensitive. And so what we have here is an example of that, which is showing a live output on this laptop screen. So if I place my finger on there, then you can see in video rates, you can see my finger. And so that is essentially something that can be scaled over large areas. That means you can wrap it around things, like it could be wrapped around a car steering wheel or a door handle, and very naturally, just by holding an object in the way that you always have, it will know that it's you and personalise that experience. And that's the kind of idea that you can do with this. And it only makes sense because it's flexible and it can be done over large areas. That's the point.
So you have spent, being a relatively small company, resources are always a challenge, and you still spent time and effort to invest in coming here to this IDTechEx Show.
Uh-huh.
How do you measure your ROI? What are you seeing here at the show that causes you to come here and exhibit?
Yeah, so what's good about this show is the mix between technology companies and end user companies.
Yeah.
So it's not only people in the supply chain, it's people that actually want this stuff and want to use it in cars or in smartwatches or in a range of different things. That's what's good about it.
How busy have you been in the last couple of days?
Very busy, that's why we've only spoken today, not yesterday.
Wonderful. Okay. So if the viewership want to be in touch with your company, what is your website address and what is the best way to reach you?
Yeah, so website address is www.flexenable.com, and you can also email us at info@flexenable.com.
Thank you so much.
Thank you.